Okay, so this is week 5. Last week you took your exam, and what I'll do with you guys tonight is I'll email you individually and send you your exam grades. That's the first thing. The second thing that I'll do is, well, I've done it already, is I uploaded a crash course video on the new unit that we're starting, or the new chapter of the new unit that we're starting on sensation and perception, along with a worksheet that goes along with that. That should be completed by the end of class tonight. And the first 3 PowerPoint presentations for sensation and perception, I uploaded in Canvas the blank presentations, and tonight I'll go through the first 3 of those presentations with you. The first one is a little bit of an introduction on sensation and perception. Hold on one second. I have a barking dog. I have to close the door. The second one is on the eye, and the third one is on the ear. So having said that, let's get started. Okay. So in the last unit, we finished by looking at the brain. And if you think about it, with the brain, one of the things the brain is designed to do is receive information from the outside world. The problem is the brain is locked inside the skull. So the question is, how does the brain receive this information from the outside world? And the answer is the 5 senses. So we have, in a sense, 5 windows that allow us access to the outside environment: vision, hearing, touch, taste, and smell. And out of those 5, most of us tend to rely on vision and hearing the most. So sensation really is more about biology. When we talk about understanding sensation and perception, sensation is about how those 5 senses actually work. But perception is how those 5 senses, after they send the information to the brain, how your brain creates meaning out of those sensations. So for instance, if you think about it, right now all I'm doing is making sounds out of my mouth. And you're hearing those sounds. But you're not just hearing random sounds. You're hearing sounds that in your mind are words. And if you put the words together, you have a language. So sensation is just the sounds coming out of my mouth. Perception is how your brain is creating meaning out of those sounds. So let's look at the definition of each of those terms. The technical, or the definition that we'll use for sensation, is the process of detecting an incoming energy through the stimulation of sensory responders. So if you think about what has to happen, in order for each of the senses to work, there has to be energy in the environment. For the eyes to work, there has to be light or electromagnetic radiation. For the ears to work, there has to be mechanical energy or vibrating air. For touch and taste, there has to be chemical energy. And for smell, there has to be chemical energy as well. I'm sorry, for touch, it's really more pressure. For taste and smell, it's chemical. So the energy, number 1, has to be in the environment. And then number 2, once the energy is sort of accessed by the sensory systems then have to turn that energy into a process or a form that your brain can use. So remember, in the last chapter, the last unit, we talked about action potentials, those electrical impulses in the brain releasing neurotransmitters. Well, that's the only language, in a sense, your brain can understand: action potentials and neurotransmitters. So there has to be a system in each one of the senses to turn that energy into a type of energy that your brain can understand. That process of changing environmental energy into energy your brain can understand is called transduction. Okay? So that's sensation. Then perception is the process of, once that information is inside, how your brain or your mind creates meaning out of it. So adds meaning to that sensory information, adds meaning to the sounds, so you hear language, not just random sounds, adds meaning to what you see, adds meaning to what you hear, what you touch, what you taste, what you smell. That's perception. Okay. So this area of psychology is probably one of the oldest areas of study in psychology. If you remember back in the beginning of the first unit, we talked a little bit about the history of psychology, and I mentioned a guy by the name of Wilhelm Wundt. He was in a lot of ways studying sensation and perception. So the study of sensation and perception is known as psychophysics. So it's ways that psychologists use to measure the strength of a stimulus and how sensitive the person who's perceiving that stimulus is to that stimulus. So when we talk about psychophysics, there's two areas that you should sort of understand. One study is called absolute thresholds. Absolute thresholds refers to the minimum amount of stimulus energy that is necessary to detect that stimulus half of the time. That's a fancy way of saying how much light has to be in the environment in order for you to see, how much sound has to be in the environment in order for you to hear. So when we talk about the absolute threshold, if it's below your absolute threshold, like light, there's not enough light and it's below your absolute threshold, you won't perceive it. Think about sound. A dog's ears are much more sensitive to ours, so they have a lower absolute threshold than we do. Same thing with the dog's sense of smell. It's much more sensitive than ours. They could smell things that we can't. It's not that the scent isn't in the environment, it is, but our sensory systems, especially our sense of smell, doesn't have the sensitivity necessary in order to perceive it. So it's below our absolute threshold. So the best way to remember this is if anything is above our absolute threshold, we can perceive it. If anything is below our absolute threshold, we can't perceive it. Then there's another threshold called the difference threshold, or sometimes referred to as the just noticeable difference. This basically has to do with how much more or less of a stimulus do you need in order to perceive a change. So if you could see the light, if you could see the light, that sounds like a philosophy question. If you could see light, how much more light do I have to add in order for you to understand that it's brighter? If you have your radio in your car up, how much more do I have to turn it up for you to perceive that it's louder or lower? So let's just say someone pours a tablespoon of sugar in a gallon of water. How much more sugar do I have to add to that gallon of water in order for you to now taste that it's sweeter? That's what we mean by the just noticeable difference. So the absolute threshold, how much stimulus energy has to be in the environment in order for you to perceive it. The just noticeable difference is how much more or less do I have to add or take away in order for you to notice that it's changed. Okay? And the just noticeable difference is based on a mathematical computation called Weber's law. So basically what Weber's law is saying is in order for you to perceive a difference between two stimuli, that stimuli, the difference has to be constant in terms of a proportion rather than an amount. Well, what does that mean? Think of it like this. If you have somebody that weighs 300 pounds and they lose 10 pounds, you're going to be less likely to perceive it because they're starting with more weight. But if you have someone that weighs 150 pounds and they lose 10 pounds, it's going to be easier to perceive it because they weigh less to start with. That's what they mean by a constant proportion. So think of it like with a stereo. If you turn your stereo up really, really loud, I'll have to turn it up even louder for you to know that it became louder. But if I only have the stereo up a quarter of a way and I turn it up a couple of notches, you'll be able to perceive that it's louder because it started off as lower. So what Weber's law is basically saying is the stronger the initial stimulus is, the more or less of it you have to add or take away in order for you to know that it's changed. The weaker the initial stimulus is, the less you'll have to add or take away in order for you to know that it changed. Concept's a little bit tricky. Okay. And that is the end of the first slide presentation. I'm going to get ready to put up presentation number 2 and presentation number 3.